Right, hello. Right, so I just want to talk, give a brief overview of. Gives a good start. Just want to give a brief overview of this particular exam. Just give a not going into anything in any detail. I should actually have added. There's a website on the bottom here, maca.co.uk. If you go there, you can get the full model answers for this particular exam, and there's also a link so that you can, from where you could download the exam paper itself. So, right, hopefully you can read this. Right, yeah. So it's starting off with the trapezium rule question. There's not a great deal I can say on this. It's just that the major error that people make is in the bracketing, and so that's about it really. Right. So I find myself saying the same things on some of these questions. People always make the same errors or carry out the same procedures. The thing is here that it's saying that it says show that such as well, that's really equal to saying prove. When you say prove, you really need to give the full procedure. No shortcuts, no fudging. So, for example. When they say that 2x minus 3 is a factor, that means that perhaps I'll do this on a separate sheet. Alright, another good start. F 3 over 2 equals 0. But some people, they just charge in and they just substitute it straight in. They say, okay, 4, 3 over 2 cubed minus 8, 3 over 2 squared plus 5, 3 over 2 plus a equals 0. And the thing is, if you've piled in without just writing that down, without giving any explanation, you're going to lose marks. You need to specifically state that if 2x minus 3 is a factor, then f of 3 over 2 equals 0. You do need to stick that fact in first before ploughing in and doing this equation. Otherwise, you're just going to lose marks. It then goes down to, I'm sorry about all these markings on here. Hence show that the equation f of x equals 0 has only one real root. So the fact is that you've given one factor, so you divide that through by that in order to get what you'll get is a quadratic factor out. And once you've got that quadratic factor out, you can show that that quadratic factor has no real solutions, and therefore this root here derived from this factor. Sorry, just let me have a look at here. Yeah, sorry. So you show that the quadratic has no real roots, and therefore the only real root is the one that you're actually given originally. There are a couple of notes that I've made about this. Is that this here is a factor. This is not the root. Some people describe this as the root. And secondly, the root is what to say? The root is essentially the point where this function crosses the x-axis. Some people went into trying to differentiate and so on. Differentiation is going to give you these stationary points, but that's not what we're after. We're finding the roots where it crosses the x-axis. Also, some people were setting, well, obviously there's all kinds of errors on things like this, but when you've got the quadratic function out, you show that there's no real roots by the fact that b squared is not greater than 4ac, i.e. from the discriminant. But some people were setting the b squared minus 4ac equal to 0 for some reason, things like that. There's all kinds of funny things. But yeah, to show that quadratic has no real roots, the easiest way is just to work out, just to show that the discriminant is not positive or 0. Right. Right, so this is fairly straightforward in a way. The radius finding the radius and the circle equation itself, given that you've got the centre, is fairly straightforward. You have this then have another standard question where they're asking you to find well, this time they're trying to find the equation of the tangent. Quite often they also, the question would be find the equation of the normal, but it's the same thing. So well, this is a bit more difficult because you've got to let me get this right. Yeah, the answer from the first part, because that got centre 2, 5. The equation of the circle will be that y minus 5 squared, and you found the radius. The radius is 10, so that would be 100 in the particular equation for the circle. And to find the equation of tangent, you first off need to find the gradient at that particular point, i.e. at 8, 3. So you need to use some implicit differentiation, so that would be 2x minus 2 plus 2 y minus 5 divided by dx equals 0. And that would eventually give you missing out a step. I'll go straight to the answer. Yeah, I stress that well, I'll put the other step in. You should never miss steps out. Okay, so that's what you would do if you're doing the exam itself. You'd stick that step in, and you'd end up with this gradient, which once you stick the values in, you can work out the gradient, which will be the gradient in numerical value, which will be 3/4. Now the equation of the tangent, given that this is at where are we? 8 minus 3. So the gradient is 3/4, and at this particular point here, the equation of the tangent will be just y minus 3 equals the gradient x minus 8. Okay, and I keep saying this because this is my recommended way to do this. I keep saying this because people do typically say write down y equals mx plus c, substitute the values in and get the c out that way. But this is more direct to my way of thinking. I would recommend you do it this way. And also another thing is that This does ask for the answer in the form ax plus by plus c equals 0. And if you don't give it in that form, then you're going to lose. Well, you're going to lose at least 1 mark. You'll be surprised at the number of people who do not follow that request. Right, so binomial, what do I need to say about this? Yeah, so you don't need, again, you don't need to fiddle this around with this binomial. It's a positive integer as the index, so you can just go straight into the binomial expression. If you were to mess around with it, such that ending up with an expression where the first term inside the bracket is 1 and the second term is such that has a magnitude less than 1. If you then did the binomial expansion, you would still get the same answer. So that's not incorrect in that sense to do that, but it's just more long-winded. So you just go straight in and do the binomial expansion for that. I won't do it because you should know that straight anyway. Yeah, I think that's all I need to say on that. 5. Right. Right, as I say, my recommendation on this is always to get the log terms on the left hand side and everything else on the right hand side. There are other techniques that people use which I find is not so transparent. So what I'm going to do here is I'm going to take everything over on the left hand side, but also simultaneously apply the logarithmic rules. So that would be log 16x x plus 1 over x plus 6 equals 3. So that's very straightforward. You can just then anti-log both sides, and that just becomes the bracket, and that just becomes, well, that's log to the power log to the base 2, so that'll just become 8. Again, that's something to watch out for. Some people I mean, to me that's the most logical way of doing it, but it's also, when you're anti-logging it, it's you know, you've got a greater chance, to my mind, of getting the right answer on the right hand side. Some people are a bit confused about taking anti-logs, you know, and if they don't do it this way, then they get the numerically the wrong value. Now, another point I can make on this, if you process that and simplify it, you get 8x minus 48 equals 0. Now, again, what you're trying to do here is you're trying to solve this equation. You know, you get something like this, always but always simplify it. I mean, this is, again, it's just something to is commonly not done. You know, if you've got a quadratic and you simplify it, then do that. It just makes things easier for yourself. And you get some weird examples of quadratics where you know, the coefficients are in fractional form and things like that, and people will still not bother to simplify it before going on to the next step, and you know, it's just becomes a bit of a mess. So I mean, you can divide through by 8, and that becomes x minus 6 equals 0. So that's the one thing you should do, going from there to there, and that simplifies everything very, very nicely. And you get 2 answers out of that quadratic, but you need to recognise that you cannot take the logarithm of a negative number, so you actually only end up with one value, which is x equals 3 over 2 is the actual answer. So I could always go on forever about the errors that people make on these logarithmic questions. If I could just mention one, log x plus 6 does definitely not equal log x plus log 6, okay? cardinal error that people make. That is definitely not true. Again, I'm sorry for all these, my own markings in red on these questions. Hopefully you can still read the questions okay. Now these are in geometric. Yeah, these are in geometric series. So in order to get an equation out of that, what you do is you equate the common ratio. So what I'm saying is that the second term divided by the first term, k divided by 2k minus 15, equals the common ratio here as well, i.e. the third term divided by the second. So that's k over 4 over k. And yep, so that's yep, so that'll hopefully show that when you process it out. You then find out what k is, and the final bit, which says calculate the value. Oh yeah, total number of values is predicted to exceed 3 million for the first time in the nth month. Calculate the value of n. Again, this is a very common question. We need a bit of curve. I'll do a new case. So the formula is always useful to actually write down the formula. And we're yeah. So this is given in thousands. So the number of downloads is given in thousands. So when it says 3 million, what you're going to do is you're going to enter 3,000, and you're looking for this expression, i.e. the summation, to be greater than 3,000. So it's first term, which is 9. I haven't actually mentioned that specifically, but once you've worked out what k is, you find that is 9. That's what I've put down there. The actual sequence is 9, 12, 16. So it's 1 minus 4 over thirds, 4 over 3 I should say, and minus 1 over 4 over 3. Did I mention the common? I don't think I mentioned the common ratio before, but the common ratio is worked out to be 4 over 3. And you go from there. But the one thing you need to watch out for here is the inequality signs. For example, it'll come down to 1 minus 4 over 3 n is less than minus 100, minus 1,000 over 9. Now the next step, I don't want to deal with a minus number. Essentially I want to log this term, so I don't want to deal with a minus number, I want a positive number. So if I write down 4 over 3, if I rejig this, treat it like an equation, rejig that, and that left hand side, then I'll take that over, that will then become 1 plus well, essentially what I've done is I've taken that over that side and that over that side. So essentially I need to rejig the equation like that. And yeah, actually that's not as bad as I thought, actually, because the one thing I was hoping to point out was that if you divide something by 3 by minus 1 or multiply 3 by minus 1, you need to reverse the sign. But here I'm just adding or subtracting, so I haven't actually reversed the sign at all really. I've just taken that over that side. and that over to that side, and then turn the inequality around. And typically also I've ended up with n log 4 over 3 is greater than log 1009 over 9. So here n is log that divided by log 4 over 3. So that's okay as well. Typically what happens here is that you're trying to find the, in most of these questions, well, I should say most of these questions in my experience, you're trying to find the log of a number less than 1. So when you divide through by a log of a number less than 1, that will be a negative. So the very fact that you're dividing through by a log of a number less than 1 will require you to reverse the sign. But that's okay here because that logarithm will be positive, so that's just straightforward. Right, it says you've got an equation for the height of the river. Show calculus to show that alpha satisfies the equation given that when t equals alpha. Now, first off, we need to differentiate. The way you're going to do that first is to simplify that. There's nothing too complicated here, there's no product rule here or anything. It's just that h equals the square root of t plus 6 3 over 2 20 minus 6 5 over 2 20 plus 17. Yeah, so that should be pretty straightforward really, but I'll do it for you. T equals a half, t minus a half, plus 3 over 2, 6 over 20, e, t to the half, minus 5 over 2, 1 over 20, t to the 3 over 2. And as I've always said, simplify expressions before you go further. I mean, it should be fairly obvious here that you need to simplify this. You're not going to work further with this mess. So it's a half, t minus a half, plus 9 over 20. One little thing, I mean, there's a lot of little things I could say here, but this is dh over dt. It is not dy by dx, which some people do write down. So you can then set that equal to 0, stationary value at here. So you set that equal to 0 and work out what the expression is. You end up with a nice quadratic equation. I'll write that down for you. I'll need to say something about this later on actually, so I'll write that down. You derive this because you're multiplying through by t to the power of half and so on to go from you're setting that equal to 0. You're setting this first derivative equal to 0 and then manipulating that equation, multiplying through by t to the power of half. For example, you end up with this, and it's only really then, it is then when you say, okay, t equals alpha. Sorry, did you see what I was saying there? I was screen. I was saying that you end up with this first derivative, you set that equal to 0, you play around with it by multiplying by t to the power of a half, for example, you end up with this equation. It's then that you say, okay, let t equal alpha and prove what it says here. Okay, at the end, you do not set t equals alpha right at the beginning and then differentiate the expression with alphas. This is just a special case. You're differentiating the general case, i.e. just t, and at the end, once you've derived your equation, you then zero in on the special case when t equals alpha. So what's it asking for now? Yeah, so you can then find out what the value of alpha is. Now this is quite important here. It says then use further calculus to prove that h is the maximum. Right, now what you're going to do then is take the second derivative. That's fairly straightforward. But what I need to point out is that you're taking the derivative of this, okay? In order to form the second derivative, you're taking the derivative of this. You are not taking the derivative of this. You're taking the derivative of this. Which is minus a quarter yep, that's right. So in general, what we need to show here is that we need to show whether the second derivative is greater than 0 or less than 0. So in a lot of cases, you don't really need to actually find a numerical value if it is immediately obvious whether the expression is going to be positive or negative. But here you do actually need to do a bit of arithmetic and find out what the value of the second derivative is, which according to my calculations is about minus 0.3. So that'll prove that it's maximum, which is what we're trying to show here. But you do need to make a statement here. I can't just say, okay, the second derivative is minus 0.3, therefore it's a maximum. I need to specifically show that I know what I'm doing, you know, i.e. dIT or dT squared is less than 0, therefore a maximum. Okay, I need to stick in that information there. Just saying, well, if I was to leave that off and just go say, okay, it's minus 0.3, therefore it's a maximum, that would lose marks. I need to state specifically that it's less than 0, therefore it's a maximum, i.e. you need to show the examiner that you know what you're doing. There's usual things here, you know, you do not set the second derivative equal to 0, which some people always want to do, and that type of thing, you know. So, right, this is, in one sense, a fairly straightforward question, but I think sometimes people are blown off course by it. They can't believe that it's so basic in a way. What you got here is consecutive prime numbers. You just need to show one example which contradicts this statement, which typically, for example, there are a couple of examples, but typically something like 7 and 11. That'll come up to 100. Stick that into here, it'll come up to 170, which is therefore a multiple of 10, therefore the counterexample is not true. Again, you need to show it in full. You don't just say, okay, stick that into there, that's 170. You then need to say, okay, 170 is a multiple of 10, therefore the statement is not true. And there are other examples, as I say, but what of the errors on this, one of the strangest errors was that people were carrying out a so-called counter statement using prime numbers which were not consecutive. It does say there consecutive, so that fits the bill, 7 and 11. But you do need to have them consecutive. Yeah, I'm just trying to. I mean, there's quite a few errors on this, technically speaking, but I think a lot of people just misunderstood the question. Really, they were trying to. They come up with two prime numbers in here, which will produce a number which is not divisible by 10, and then somehow they took that as a counterexample. They just appeared not to have read the question properly. You need to produce two consecutive prime numbers such that when they go in there, they produce a number which is a multiple of 10, thereby counteracting this statement. And this one here, again, when it says prove by exhaustion, all you need to do is really, well, when I say all you need to do, you just need to list down all the possible variations here, which there aren't all that many. There's really 4 separate values of this which satisfy the conditions, and therefore you can just show directly from those 4 outcomes that this is true. It's fairly straightforward. Right. So. My recommendation again on this is to process the inside the bracket and get rid of the brackets. A lot of people really made a quite bad mess on this by not doing that. By keeping the bracket and so on. But to my mind, if you convert the tangent, so that's sine theta cos theta divided by sine theta plus 3 equals 11 minus 5 cos theta. So straight away that becomes 3 sine squared theta plus 9 cos theta equals 11 minus 5 cos theta. Sine squared theta equals 1 minus cos squared theta. So you're going to get an equation in pure in terms of cos, which is what you want. If you can get an equation in terms of cosine, that is the way to go. That's what you've got. Yep. So that's proven. Hence solve. So essentially now it says solve that, but obviously due to this substitution, this derivation, you're now effectively trying to solve this one here. And this will factorize. Oh, yeah, there's a slight difference in it now is that, instead of theta, you now have got 2x. So using this same formula, but instead of theta, it's 2x. So that'll be 2x minus 2. This is a separate question now. B. 2 cos 2x minus 4. Yeah, I mean, again, this is something to remember, watch out for, really. So, sorry. Oh, sorry about that. Yeah, from memory, I think a lot of people just did not notice that it went from theta to 2x. So that can be rejected as producing cosine 2x equals 4, and I just 0 on this, and that'll give me 2 cosine 2x. Again, I'm missing out a few lines here for some reason. You don't want to do that when you're in the exam. You stick in at least another line to go from it there to there. Oh no, sorry, that would lead That will lead directly from there. Right, sorry, I apologise for that. Yeah. No, sorry, that will go. I'll go straight from there to there. That's okay. I'm not missing out any lines here. So therefore, cosine 2x equals. No, sorry, there is a 3 there, isn't it? 2 over 3. Cosine 2x equals 2 over 3. Now again, my preferred way of doing this is I've got cosine 2x equals 2 over 3. So my preferred way of doing this would be to take 2x equals I've got 48, 18. I should have spaced these out a bit more so that these would all go on one line. Yeah, so it's gone for cosine again. This is something I'm always writing down, to the effect that cosine of theta, theta equals n 360 plus or minus sine of minus 1. Theta. So you find out the principal value, and it's always 0 plus or minus the principal value, 360 plus or minus the principal value, 720 plus or minus the principal value. So it's always dead easy with the cosine. So I've done that here, and I've got out four terms, because I know that I'm then going to have to divide through by 2, and I've worked it out that when I divide through by 2, I'll get the full range required. So I get 4 expressions here, which are the 4 solutions to the original question. Yeah, I mean, a lot of people, they do all kinds of diagrams, or sinusoidal diagrams and things like this, trying to find out all the different values for cosines. But to my mind, that's just a waste of time. You stick all the basic values down right at the beginning and just work through line by line to arrive at the answers on the final line, instead of just deriving one specific example and then trying to fiddle around trying to work out all the extra values later on. Right. Now this is a calculus which in one sense is fairly straightforward, but is always you always have to be a bit careful. So yeah, first off, it involves an integration. So you want to x minus k squared over square root of x. So this looks complicated, but really you need to just simplify it out first. So it becomes x squared minus 2kx plus k squared over square root of x. It's always dx dx, and that then becomes x 3 over 2 minus 2kx a half x minus a half dx, and so you integrate that. Now it then asks you to find r, so I don't think I won't do this in full, but I'll just give an explanation. This always, things like this always cause problems for people. You just need to be a bit careful. Now you've integrated this expression. This is the line which you've just integrated. Now you need to be aware of what that shows. I mean, it's given us, I'm assuming that you're trying to find out what R is. That's the final bit. Find the region R. Now, what you've calculated by integrating is the area under the line. You haven't found out what R is. You found out that hatch area there, and that's the essential bit you need to understand. You can work out what these coordinates of A and B are. So what you then need to do is you need to work out what the area of this trapezium is. You find out what the area of this trapezium is. That's not particularly accurate down there, is it? The hatching is just to the right of that vertical line. So you need to find out what the area of this trapezium is, and then you subtract what the value that you found from your integration, this integration here. You substitute the values in, you found out a numerical value. But you take the area of that trapezium, you subtract the numerical value springing from your integration, and that will leave you with R. So you just need to be a bit careful here. The last question I think is fairly straightforward. I think the one thing I could say about this is just layout. You're given these expressions up here, so therefore you can work out what U2 and U3 are. I think most people are happy with that. But then you could, then you were told to work out this summation. So I can tell you that you'd end up. I mean, it's a matter of actually writing down what you're doing. I mean, the process is fairly simple. It's just that if you don't give any explanation, or you don't do it in a sort of transparent way, it can get a bit of a mess and very hard to understand. So, for example, you could say that by substitution you're going to get something like this. But once you get to this part, there is a certain amount of, instead of just ploughing on with this expression, you can simplify it first. You know, it's not a great deal of simplification, but it all helps greatly. You then substitute in B equals, so you'd say, okay, now, or since B equals A plus 9, you can then substitute that in. Instead of just leaving that out and just sticking B equals A plus 9, just replacing B's with A plus 9s, you could at least put a bit of a note in saying that that's what you're going to do. B equals A plus 9, therefore you're going to substitute it into that equation. Yeah, so that's the thing. That's the only little thing I'd say on that. When I say little thing, it would help greatly in marking, and if you did follow out a systematic method like this, you know, explaining to the examiner what you're doing and simplifying where required and so on. Anyway, that's all I need to say on this. So thanks very much again if you're still with me, and cheers for now.